Let's talk about equations of lines and modeling. On this next slide, if you want to pause it, go ahead and read over this. These are the objectives we're going to cover in this section. Slope-intercept form. We know that we have it written in the format of y equals mx plus b, but we also know that we can have it written in a function notation, and this one's going to be called f of x is equal to mx plus b, where m is my slope and b is my y-intercept. It's also, you're going to hear it called slope y-intercept form or slope-intercept equation. So those are all correct notations. So in this first example here, we have a line of a slope that's a -7/9, and it gave us the y-intercept. So it made it really simpler and less work for us. We're just going to write it in slope-intercept form, and we're going to write it in function slope-intercept form. So we know this is m, and we know this is b, because whenever it crosses the y-axis, we get x for 0, or yeah, x is 0. And once we know all of this, we can write it in the format. Now I got y is equal to the -7/9 x. And since b here is positive, we're going to say plus 16. But we can also write it in a function notation and call it function's name x, or f of x. And then we have our formula written, our equation, and our function. Now, what happens is they gave us a slope, and it says -2/3, and it contains these points, meaning that the line passes through these points here, but they want you to write it in slope-intercept form. So we don't know what b is because it wasn't given to us as far as the y-intercept goes. So let's solve for it. So what I'm going to do is I'm going to plug in and remember we're using this one here. I'm going to plug in what I know. I know that my slope is equal to this -2/3, so it's written in there. We know what x and y is because we have this order pair that the line passes through, so let's plug those in. My y is 6, and my x is -3 plus b. All right, we're solving for b because we got part of our equation that we can type in. We could say y equals that -2/3 x, but we don't know what b is. And if they wanted you to write it as a function notation, we got part of it as well. All right. Now, I'm going to have to clean this up a little bit. For my own self, I like to go ahead and put the whole number over 1. And notice that I have 3 divided by 3, right? That reduces to 1. I got negative times this negative. Well, that gives me a positive. So now what do I have? I have 6 is equal to 2 plus b. And 2 is positive, so let's subtract it from both sides. So I got 6 minus 2, which is 4, equals b. Oh, wow. I know what b is. B is positive 4. So I can come back and plug it in my equation and my, whoops, I don't want to write b. Excuse me, guys. I just got carried away and wrote b. We want to write 4 because that's what b is. And now we got our answer. And from this, we can actually plot it on our graph. So this one here is just showing you how to work it out. Now let's talk about point slope equation. So a point slope equation says that we have y is minus the y from an order pair that the line crosses through, m, which is my slope, times the x minus the x coming from that same order pair that the y came from. And we're going to plug it in. So I'm going to use an example. So let's go back to our slope of a -2/3. And let's say we have 3, 4. Say the line's passing through 3, 4. So I need to solve for the point slope form. So I want that. And then let's put it in slope intercept form. Okay. So I'm going to say y minus, and I'm going to pull my y value from this order pair. going to be equal to my slope. Well, the slope was given to us, a negative 2/3. And it's going to be multiplied to my x minus, and I'm going to pull my x value from that order pair. And now I'm finishing up. All right. Now, there's nothing here that needs to be cleaned up. You might have a negative times negative. You have to clean it up if you have that before you say that's my point slope. So there's my point slope. Now, from here, let's solve for our slope-intercept form. So in order to do that, I need to take this negative 2/3 and distribute it. So I have y minus that 4 equals negative 2/3 times that x. And then I have the negative 2/3 times that negative 3. So I'm going to go ahead and put that negative 3 over 1. And I see that I got negative times negative, which is positive. 3 divides 3 one time. So now I have y is equal, or excuse me, we can't move the 4 just yet. I mean, you can if you want to do it in 2 steps. Just be careful when you do that. So y minus 4 equals negative 2/3 x. And we got that negative times negative. Okay, so now we got 2 times 1, so positive 2. Now, let's get the y by itself by adding the 4 to both sides, because that 4 is negative. And negative 4 plus 4 gives me 0, and that's what we want. So now we got y is equal to negative 2/3 x. 2 plus 4 is 6. And now I have it in my slope-intercept form. Okay, moving on to the next slide. They said, find this equation of a line containing these two order pairs. So I'm going to, I want to use this. I'm going to type it up on this, or write it on a blank piece of paper so I have more room. So we have order pair 2, 3, and order pair 1, negative 4. I want to double check, just make sure. Yeah. All right. So let's solve for it. So we have this line passing through these points, and you're told to put it in point slope form and then put it in slope intercept form. So we don't know what the slope is. We don't know what the y-intercept is. So we're going to have to do some work. The very first thing I need to do is solve for the slope. I'm going to call this order pair x1, y1. I'm going to call this order pair. Actually, if you wish to go graph it on the graph, you would have 1, negative 4 right here. And then you would have 2, positive 3 right here. So actually, this would be order pair 2. And this would be order pair 1. Because remember, we read the graph left to right. So what I'm going to do is I'm going to take the change in y. So I got order pair 2 minus order pair 1 divided by order pair 2 minus order pair 1. And again, I plotted on the graph from red left to right. This 1 comma negative 4 came before the 2 comma 3. So let's clean this up. So I got negative times negative, so that's positive. So I got 3 plus 4 over 2 minus 1. You could have done multiple steps here if you wanted to. 3 plus 4 is 7. 2 minus 1 is 1. So it's 7, but if I was to go plot it on the graph, we'd want to use the 7 over 1, because remember, it'd go up 7 y values to the right, 1 x value. So you need this for graphing, but to put into your actual answer or equation or function, we would want the whole number, okay? So now I'm going to use the point slope formula. So it doesn't matter which order pair you pick here to plug in. Just make sure whichever one you use, you use the same y and x from that same order pair is what I'm trying to say. I'm going to choose this order pair. You could have chose the other one. That's fine. So now I got y minus, from my order pair I'm picking, my y value is negative 4. equals, and my slope is 7. Now I got x minus my x value from that order pair is 1. Okay, so now what I'm going to do is I want to distribute this 7 to everything. Well, hang on. We're going to write it as point slope formula. I got ahead of myself. Okay, so what I need to do is I need to take this negative times negative because we got to clean it up before I can say it's my point slope. Negative times negative is positive. Okay, now I can say, oh, this is my point slope form. Okay, so now let's solve for a slope intercept form. What I'm going to do is I'm going to distribute this positive 7 to everything in that parentheses. So 7 times x, 7 times negative 1. So let me scroll down just a little bit. Now I'm going to solve for y. So I'm going to have to subtract this 4 from both sides since it's positive. We want it to go to 0 here. And now I have y is equal to 7x. I got negative 7 minus 4. So it's basically saying you're in the hole $7. You borrow $4 more. You're in the hole $11. And now I have it in my slope intercept form. From here, I can graph this on my graph. Remember, you're going to, oh, and let's just talk about it right quick. So my slope y-intercept here, because you may be asked what it is. We know it's always 0 for x. And in this one here, we got negative 11. So it crosses the y-axis. We would plot it first. And from there, we would plot our slope. In this case, our slope is 7 over 1, which is seen as 7. Okay. So you can review this one. Let's move on. This one here is talking about vertical lines are parallel. Non-vertical lines are parallel if and only if they have the same slope. So this is just telling you in words. Let's just look at it. If you have a parallel line, they can run beside each other. Parallel lines, run beside each other. They can run vertically. They can run at a slant. They can run horizontally. As long as they're running beside each other, they're parallel lines. They have their slopes. And I'm going to call this line 1 and line 2. Their slopes are equal. They will have the same slopes. If they're not parallel, then they're not going to have the same slopes. Slope 1 will not equal slope 2. Okay. And if you notice, these lines do not have a 90-degree angle between them. So these are just going to be called non-parallel. The slopes are not equal. Perpendicular lines, though, are different. They have, they're not parallel, but they have 90-degree angles between them. Whoops, this one here does not. I was trying to draw it and it didn't come out right. So this here is not. So you see it's not perpendicular. So it's neither parallel nor perpendicular. This is. So the two end graphs here are perpendicular. So let's talk about it. Let's call this line slope 1, slope 2, or line 1, line 2, whichever one you want to call it. If you have a perpendicular line, think of it as an intersection. It's a 4-way stop. You're at one part of it. Someone else is at the other part. It's a 90-degree angle all the way around, right? If it's perpendicular, that means it has a 90-degree angle between each line. If that is so, then your slopes, and I'm going to just say slope 1, is the opposite sign and reciprocal number of slope 2, vice versa. So if my slope 1 is a negative half, then my slope 2 would be a positive 2. You would have opposite signs, reciprocal number, meaning flip the number. Okay? Again, if this is my line 1 and this is my line 2, and this here is a negative slope, and this slope here, guys, is actually 0. On this first one, it should have been 0, okay? And then this one here, slope is undefined, but yet they're opposite and reciprocal of each other. So you would actually have to do some work, and we can figure that out. I'm just trying to come up with an example for you to visually see it. This other one will be a better example. So let's look at it. So this is a negative slope. I'm going to make up a number. Let's just say it's negative 2/3. Then my slope 2 would be a positive 3/2. So I'm just trying to give you a visualization of it. All right, let's move on. So perpendicular lines, if one is vertical, x equals a, and the other one, that means the other one's horizontal, then that means my equation will be y equals b. That makes sense, right? We've talked about this in previous sections. Okay, so we're going to determine if they're parallel, perpendicular, or neither. Okay, so I'm going to write this down, so you have to give me a second to get this on my Word doc. Okay, so we had what? Y plus 2 equals 5x. Let's call this line 1. Y plus 2 equals 5x. Let's call line 2. Five y plus x equals, I believe it's negative 15. I just want to double check. All right. Now we want to determine if they're perpendicular or parallel or neither. So what we need to do is get it in point slope form. So for line 1, I'm going to subtract the 2 from both sides. I got y is equal to 5x minus 2. So that worked out nice and easy. This line 2, though, I need to get this x to the other side. And since it's positive, I'm going to subtract it. I get 5y is equal to negative x minus 15. I have a coefficient of positive 5 on y, so I need to divide by that 5. So you have y with a positive 1 coefficient. So I'm going to divide each part by it. So now I have what? Negative 1/5 x minus 3. So the slopes, oh wow, look at it. This slope 1 is a positive 5. This slope 2 is a negative 1/5. So the slopes are opposite and reciprocal. So this tells me this is perpendicular. Okay. Voila, it's perpendicular. Yay. Now, if the slopes were equal, we would have said parallel. If it didn't give us either one of those options, we would have said neither. All right. So we're going to do the same on that one. I'll let you practice on that one. And this one too as well. So I want to move on. So this one says write the equation of this line, a parallel to the parallel and perpendicular. So what I want to do is I want to come and write this down on my paper. Let's just do this one here. Right here. We're going to start here. Let me get it says that we have line 1, which is 4y minus x. So let's call this line 1. 4y minus x is equal to, let's see, what was it equal to? I believe 20. Yes. 20. And let's call this line 2. It said it passed through this order pair. Or line 2's line passes through this order pair, 2, negative 3. All right. Okay, so what I'm going to do is we're going to do the perpendicular and the parallel. And then we got parallel they want us to do, okay? So let's solve for this. Well, I'm going to have to add the x to both sides because it's negative. So I got 4y is equal to x plus 20. I'm going to divide by the 4 because the coefficient on y needs to be positive 1 and it's positive 4. All right, so I got 1/4 x plus 5. So that's line 1. I'm going to highlight it just so I can see it. That's line 1. Let's come over here to line 2. All they gave us was 2 comma -3. So we got some work to do. We need to know what is my slope in order to figure out the rest, right? So if it's perpendicular, then we know that line 1 here is equal to that 1/4, and that means line 2 is equal to -4. If it's parallel, then line 1 equals line 2, which is equal to that 1/4. So we need to do our sections. I'm going to do the perpendicular line. You could do either one you want to do first, or if the instructions tell you to do one versus the other one first. Okay, so I'm going to do the perpendicular. So I'm going to take that line 2 and slope 2. And I'm going to say y is equal to mx plus b. If you want to use the point slope formula, you go right ahead. You can use it. I like using this method, but I'm not saying this one's better than the other. It's a preference. So my y from that order pair from line 2 is -3. My slope 2 that's perpendicular to slope 1 is going to be a -4, and my x from that order pair is 2 plus b. So now I'm going to just clean this up. I'm going to scroll down just a little bit now that I got my perpendicular line written. I'm going to distribute these two. -4 times +2 is a -8 plus b. I'm going to add the 8 to both sides because it's a -8. So I have $8 and I spent 3, leaves me with 5b. So now I got what I need. I can come up here. So my perpendicular line is going to be equal to -4x plus 5. So that's my perpendicular line. Now let's solve for the parallel line. Now I'm going to take my line to the order pair that I used that was given to me, and my slope 2 on the parallel. So I got y equals mx plus b. Let's plug in. My y is -3. My slope is 1/4 times my x. And I noticed that I can put a 1 underneath this 2. 2 goes in itself once and goes into 4 2 times. So now I have -3 is equal to 1/2 plus b. And since it's a positive half, I'm going to subtract it from both sides. And let's do some basic math. In order to add or subtract fractions, we have to have a common denominator. Let's go ahead and bring down our equals b. And in this case here, my denominator has a 1 and it has a 2. So the smallest number that 2 and 1 will go into is 2. So that means I need to multiply this fraction top and bottom by 2. So now I got 2 times -3. Let me scroll down. Over 2 times 1, which is 2, minus that half. So 2 times -3 is -6 over 2 minus that half. Now I can say -6 minus 1 over 2. Now I can see, oh, -6. You're in the hole $6. You borrow one more dollar. Now you're in the hole 7, and it's -7/2. So now I know what my perpendicular line is. My perpendicular, or excuse me, my parallel line. We already did the perpendicular. Is equal to that 1/4 x minus 7/2. And there's my parallel line. And I'm just double check, make sure I didn't write something. Okay, good deal. All right. So you can look through these slides. I'm going to bypass them. Now let's talk about mathematical models. So I'm going to read just a little bit. So when you read a when a real world problem can be described in mathematical language, we have a mathematical model. So it's an application problem, right? The mathematical model gives results that allow one to predict what will happen in the real world situation. So we use this like in statistics, data analysis. I mean, there's many reasons you would use application problems. If the predictions are inaccurate or the results of the experimentation do not conform to the model must be changed or discarded. So basically, what is the question that it's asking for? Does your answer make sense? Mathematical modeling can be an ongoing process. And sometimes you might have had an error in your calculation. Sometimes the model itself just will not work. And the model is an equation that we derived at to fit it. So in general, we try to find the function that fits as well as possible. The observation, data, theoretical reasoning, and common sense. We call this curve fitting. It is one aspect of mathematical modeling. Let's sum data and related graphs or scatter plots and determine whether a linear function seems to fit the data. So as you see here, they said that we have this cost of 30-second Super Bowl commercial has increased 1.6 million from 2010 to 2015. So the model data in the table below with the linear function, then we're going to estimate it. So if you know how to use Excel, you can actually plot this data and it would give you a regression line to let you know. And in this case here, it's linear. So this example, it says we're going to choose 2 of any of these plots on that right there. So we're going to make a XY table. We have our order pairs because when you plot it on there, it's going to give us some data. So, whoops, they said that we're going to pick these 2 order pairs from that table. And we're going to find the slope. Of course, we're going to subtract the y2 from the y1 and divide it by x2 minus x1. And then we're going to get us, and they put it in decimal form because we're actually putting it into a model, an application of explanations. It's better to understand it than it would be if I said 0.9 thirds, right? We only need it in fraction form when we're graphing it. And then they said, okay, let's pick either one of the order pair, and they picked this order pair, and we put it in our point slope formula and derived at our slope intercept form, and which gave us a math model that helps explain our data. And if we're increasing or decreasing. In this case, the cost of the Super Bowl commercials are continuously always on the rise. Okay, so now a linear regression. A linear regression is a procedure that can be used to model a set of data using a linear function. We're going to consider the data on the cost of the 30-second Super Bowl commercial given previously, then use the function to predict the cost of the 30-second commercial in 2018. When we can fit the regression line in the form of the slope intercept form, the data using the regression line featured on a graphing calculator. So you can use a graphing calculator as well. I like Excel because it's easier for me to see it. It's bigger, it's spread out, and it, but if you plug it into your graphing calculator, it would also give you a line too, and then you get these points, and those points you would want to use. And I apologize that this here has cut off. So this here would be my linear model. Okay. Now, let's go on. So fit a regression line to the data given in the table, then we're going to use the function to predict the cost. So we got our table, we got our order pairs, and now we're going to predict the cost. You put it in your graphing calculator, and again, it gives you these points. If y'all, and this is a scatter plot, as you can see. If y'all have any questions or help or need any help, please just reach out to me. This is giving you steps on how to use your graphing calculator. If you want to know how to use the Excel, please reach out to me. I'll be happy to help you. And then it's just telling you to substitute 8 into the regression model, and it's going to give you the cost that was predicted for 2018 and so on, and move on. So practice on that. This one here, the correlation coefficient. On some graphing calculators with the diagnostic feature turned on, a constant R between -1 and 1, called the coefficient of the linear correlation, appears with the equation of the regression line, used to describe the strength of the linear relationship between X and Y. The closer the absolute value of R is to 1, the better the correlation is, which makes sense because, I mean, the more you reach negative, it's not as correlated. A positive value of R indicates that the regression line has a positive slope. The negative value of that R tells us it's a negative slope. So it's a positive slope if R is positive. It's a negative slope if R is negative. So our correlation coefficient. So if you look at these scatter plots, this first one here, all points on the regression line, it gives us R is equal to 1. Look, it's a straight line. It's nice. It's pretty. Now, if R is not equal to 1, but it's approaching 1, and it's like 0.91, I mean, it's got a high positive correlation, meaning that it's closer to 1. It's going to be, you can draw a straight line between them. They're going to be all around it. However, the further away R gets away from 1, it becomes a low positive correlation, and it's positive. So all these R's are still positive. You notice that these scatter plots are moving away from the line, the linear line, the regression line that we plot in there. However, if the R is negative, oh, and look at this, R is positive, so it rises left to right, okay? But look here, the R is negative, so we're falling left to right. And if R is -1, you notice they're all staying on the linear line. If R is close to 1, but not 1, and they're again doing the same format, they're scattering around that line. But the further away R gets from 1, the further away these dots get from the regression line. Thank you.